because we solve lots of different kinds of equations. Let's do some of the main ones that we've talked about. We've already solved a couple of equations in the context of translating and then solving, so let's do one a little more complicated. Actually, let's do one that uses the distributive property. What if I said solve for x? And I had something like, I don't know, 3 times the quantity x plus 5 minus 2 equals 2x minus 8. Whenever I say solve for x, I'm looking for the x value that makes this equation work, that makes this side equal this side. That's all I'm doing. In terms of algebra, the way I do that is I try to get x isolated. I try to get x all by itself, either on the left-hand side or on the right-hand side. It really doesn't matter. So I'm going to do this by distributing, by simplifying, by combining like terms. So let's give it a whirl. I'm going to start by distributing that 3. Distributive property in action. There we go. Minus 2 equals 2x minus 8. Are we feeling okay so far? Now, I like cleaning things up on each side before I start moving things. So let's see over here. Do I have any like terms? Doesn't look like anything goes with x's, but ooh, 15 minus 2. I can combine those to get a 13. This looks pretty tidy over here already. So now I'm going to be moving things left and right. Let's see. Let's move our x's over here. I'm going to subtract 2x from this side. Of course, whatever you do to one side of the equation, you have to do the same thing to the other. So that gives me 3x minus 2x is x, plus 13 equals, don't forget that subtraction makes that 8 a negative. X is almost by itself. Let's get rid of that pesky 13. Those become 0, right? Those are called additive inverses, by the way. Let's see, negative 8, negative 13, negative 8 and negative 13 more gives me a negative 21. Oh, hey, x is by itself. Am I done? I'm done. Now, if we wanted to check this, you would substitute the 21 back into the original problem. And you should always do this. It's nice to know that you did it right. So I'm going to the original problem. I'm replacing that x with my negative 21. I'm substituting in the negative 21 whenever I see x. And this is when your calculator can be handy. You can just put that whole kit and caboodle, left to right, in your calculator, and make sure you get the same thing over here. Does that make sense? So if I did all of this out, let's see, I believe I would get a negative 50. Did I do that right? On this side, when I do everything, I also get a negative 50. Does negative 50 equal negative 50? Last time I checked it did. So I must have been successful. X does in fact equal negative 21. It is the x value that makes this equation true. Okay? That one wasn't too bad. Here we go. A proportion. Like if I had x over 4 equals x plus 1 over, let's say, 6. All right? Now, there are lots of ways that we've talked about doing this. But when you have a proportion, that is a fraction equal to a fraction, one nifty thing that we discovered was that the product of the means equals the product of the extremes. You're going to learn more about this in geometry and see how this works geometrically. But here are the means right here. These are the means. So the product means I multiply those together. So 4 times x plus 1. Don't forget those parentheses. You want to show the world you multiply 4 times that whole quantity equals the product of the extremes. These guys are the extremes. They're on the outside of that proportion. X times 6, I can write that as x times 6, or we usually write it 6 times x, or 6x. All right. Well, heck, this looks a lot easier to solve. Let's solve this. Let's solve it by starting by distributing. We did that before. 4 times x plus 4 equals 6x. Let's see, to get my x's on one side, well, there's a 4 here, so I think I'm going to move my x's to the right-hand side. I think that's probably the easiest way to go. Those are additive inverses. Those go away. So I have a 4 equals 6x minus 4x is 2x, last time I checked. All right, I'm almost there. Zipping up here. So 4 equals 2 times x. X is not quite alone. What am I going to do to get x by itself? Divide by 2. So I have 2 equals x. You could write that x equals 2 if you like, but 2 equals x is fine. And I'm done. That's the x value that makes this proportion true. Should we check it? Why not? Let's do our little checkaroo over here. Check. All right, so I'm thinking my x is 2. Let's replace that x, substitute 2 for the x, over 4. I'm hoping this equals x plus 1, so 2 plus 1 over 6. Fingers crossed. Let's see. 2 over 4. Does that equal 3 over 6? Oh, sure they do. 2 over 4, isn't that the same as 1/2? 3 over 6, isn't that the same as 1/2? My check worked. Beautiful. So my solution is, in fact, x equals 2. I solved that equation. I solved that proportion. Well done. Now, sometimes I ask you to solve an equation that just has a whole bunch of variables in it. And I know we run screaming from the room as soon as you see something more than an x. But really, don't panic. You're going to solve it the same way you just solve anything. Let's just say I have ax plus b equals c. All right? And I say solve for x. In other words, get x by itself. Again, don't run screaming from the room. Just say, I can do this. Let's pretend that a is a 3, the b is a 4, and the c is a 5. Well, how would you solve it? Let's see. You would subtract 4 first. Right? All right, so can I subtract b from both sides? So I have a times x equals, this is the part that freaks people out. They say, wait, what's c minus b? Well, those aren't like terms. So c minus b is just c minus b. That's all you can do. So far, so good? Let's go back to our little trial thing. To get x by itself, you would divide by 3. X equals 1/3 in this made-up problem. Well, let's do the same thing here. How am I going to get x by itself? Let's get rid of that a. We can divide by a. A divided by a is 1, so that gets rid of the a there. Of course, whatever I do to one side, I have to do to the other. Oh, that's it. C minus b over a. I have just solved for x. That wasn't that bad. Now again, sometimes you'll get a little confused because they might not say solve for x. They might say, what is an expression for x if ax plus b equals c? Or they might say, x equals what if ax plus b equals c? But just be strong, be courageous, and say, I know how to do this. I'm just going to do my algebra steps, balancing each side of the equation, and get x all by itself.
do.